बच्चों मैं अब आपको केमिस्ट्री के सेकंड चैप्टर स्ट्रक्चर ऑफ एटम के ऑब्जेक्टिव्स बताऊंगी, है ना। आफ्टर स्टडिंग दिस यूनिट यू विल बी एबल टू नो अबाउट द डिस्कवरी ऑफ इलेक्ट्रॉन, प्रोटॉन एंड न्यूट्रॉन एंड देयर कैरेक्टरिस्टिक्स. Second, you will be able to describe Thomson model of atom, Rutherford model and Bohr atomic model, है ना. Understand the important features of quantum mechanical model of atom. Understand nature of electromagnetic radiation and Planck's quantum theory. Explain the photoelectric effect and describe features of atomic spectra. You will be able to state the de Broglie's relation and Heisenberg uncertainty principle. Define an atomic orbital in terms of quantum numbers. State Aufbau principle, Pauli exclusion principle and Hund's rule of maximum multiplicity. And you will be able to write the electronic configuration of all the elements. Okay, so these are the objectives of learning this second chapter. Now let me read the summary for you to give you an overview of the chapter. It is a big chapter and so many numericals are given at the back, 67 numericals. Do all. Summary. Atoms are building blocks of elements. They are smallest part of an element that chemically react. The first atomic theory proposed by John Dalton in 1808 regarded atom as the ultimate indivisible particle of matter. Towards the end of the 19th century, it was proved experimentally that atoms are divisible and consist of three fundamental particles: electrons, protons and neutrons. The discovery of subatomic particles led to the proposal of various atomic models to explain the structure of atom. Thomson in 1898 proposed that an atom consists of uniform sphere of positive electricity with electrons embedded into it. This model, in which mass of the atom is considered to be evenly spread over the atom, was proved wrong by Rutherford's famous alpha particle scattering experiment in 1909. The Rutherford concluded that atom is made up of tiny positively charged nucleus at its center and electrons revolving around in a circular orbits. Rutherford model, which resembles a solar system, was no doubt an improvement over Thomson model, but it could not account for the stability of the atom. That is why the electrons does not fall into the nucleus. Further, it was also silent about the electronic structure of atom, that is about the distribution and relative energies of electrons around the nucleus. The difficulties of the Rutherford model was overcome by Niels Bohr in 1913. In his model of the hydrogen atom, Bohr postulated that electron moves around the nucleus in circular orbits. Only certain orbits can exist and each orbit corresponds to a specific energy. Bohr calculated the energy of electron in various orbits and for each orbit predicted the distance between the nucleus and the electron. Bohr model, though offering a satisfactory model for explaining the spectra of hydrogen atom, could not explain the spectra of multi-electronic atoms. The reason for this was soon discovered. In Bohr model, an electron is regarded as a charged particle moving in a well-defined circular orbit about the nucleus. The wave character of the electron is ignored in Bohr's theory. है ना, पता लग गया ना ड्रॉबैक क्या था बोर्स थ्योरी का. एन ऑर्बिट इज अ क्लियरली डिफाइंड पाथ and this path can completely be defined only if both the exact position and the exact velocity of the electron at the same time are known. This is actually not possible according to the Heisenberg uncertainty principle. Bohr model of the hydrogen atom therefore not only ignores the dual behavior of electron but also contradicts Heisenberg uncertainty principle. Edwin Schrödinger in 1926 proposed an equation called Schrödinger equation to describe the electron distributions in space and allowed energy levels in atoms. This equation incorporates de Broglie concept of wave particle duality and is consistent with Heisenberg uncertainty principle. When Schrödinger equation is solved for the electron in a hydrogen atom, the solution gives the possible energy states the electron can occupy and the corresponding wave functions, you know, which is in fact are the mathematical functions of the electron associated with each energy state. These quantized energy states and corresponding wave functions, which are characterized by a set of three quantum numbers: principal quantum number N, azimuthal quantum number L, magnetic quantum number ML, arise as a natural consequence in the solution of the Schrödinger equation. The restrictions on the values of these three quantum numbers also come naturally from this solution. The quantum mechanical model of the hydrogen atom successfully predicts all aspects of the hydrogen atom spectrum, including some phenomena that could not be explained by the Bose model. According to the quantum mechanical model of the atom, the electron distribution of an atom containing a number of electrons is divided into shells. The shells, in turn, are thought to consist of one or more subshells, and subshells are assumed to be composed of one or more orbitals, which the electrons occupy. For while for hydrogen and hydrogen like systems such as helium plus, lithium 2 plus, etc., all the orbitals within a given shell have same energy. The energy of the other orbitals in a multi-electron atom depends on the value of n and क्या लिख दिया ये हाँ L azimuthal quantum number. The lower the value of n plus L for an orbital, the lower is the its energy. If two orbitals have same n plus L value, then the orbital with lower value of n has the lower energy. In an atom, many such orbitals are possible and electrons are filled in those orbitals in order of increasing energy in accordance with Pauli exclusion principle. No two electrons in an atom can have the same set of four quantum numbers, and Hund's rule of maximum multiplicity. Pairing of electron in the orbital belonging to the same subshell does not take place until each orbital belonging to that subshell has got one electron. Each is singly occupied. This forms the basis of the electronic structure of atoms.